Hello, in this video, I'm going to be showing you how to draw a Bohr-Rutherford diagram for carbon atom, sodium atom, oxygen atom, chlorine ion, magnesium ion, and aluminium ion. So we'll start with the carbon. The first thing we do is to draw out the atomic notation for carbon. So carbon is represented by C, and that is the elemental symbol of carbon is C, and here you have the mass number, which is 12, and the atomic number is 6. Now, what we do is to write them out. So we have mass number to be equals to 12, atomic number equals to 6, and note that atomic number is equals to is the same thing as number of protons, and also it equals the number of electrons in neutral atom. Now, carbon is a neutral atom. So all of these ones that are carbon atom, sodium atom, oxygen atom that was given here, they are all neutral atoms. So in neutral atoms, number of protons equals number of electrons. And of course, that would mean that it's also equal to the atomic number, right? So it means that we have number of electrons equals to 6. And we can denote this by writing saying 6 electrons. Okay. Then number of protons, we can also write it as this P plus. Okay, this is how we denote protons. And then neutrons. To calculate neutrons, number of neutrons, which I will represent as this, will be equals to mass number minus atomic number. So here you have 12 minus 6, which is equals to 6. So we have these three things is what we need to draw our Bohr-Rutherford diagram. So here we have 6 neutrons. So now we have all this information, we can go ahead to draw our Bohr-Rutherford diagram. So note that we have 6 electrons, 6 protons, and 6 neutrons. Okay. All right. So the first step is to put our protons and neutrons, which is 6p plus and 6 neutrons. Now, after that, the next step is to fill up the shells with electrons. We start filling the inner shell, or the first shell, we have maximum of 2. So this is the first shell, it will have a maximum of 2 electrons, and this is how you write them beside each other. Now that you filled in the first shell, the next shells, all the other shells that comes after the inner shells, we have 8 maximum electrons. So inner shell has 2 maximum electrons, and the other shells will have 8 maximum electrons. So after this, you put in your second shell. Start with 2. Of course, the inner shell has 2. So 6 minus 2 will give you 4. So you remaining 4. So at this end, you just put in 4 electrons. So this is the Bohr-Rutherford diagram for carbon atom. So let's go to sodium. So sodium, we'll first write out the atomic notation. So sodium has atomic mass of 23 and atomic number of 11. So this is the atomic notation for sodium, and Na is the elemental symbol. So now we know that the mass number is 23 and the atomic number is 11, which is also same as proton number. And because this is a neutral atom, it also has 11 electrons. Now the neutron would be mass number, which is this, minus the atomic number. So you have 23 minus 11, which is 12. So we have 12 neutrons. Okay. So now we have these three major informations that is required to draw the Bohr-Rutherford diagram. We can then start the drawing. Now we put the 11 protons inside here and 12 neutrons here. Then the next is our first shell. Your first shell will start with 2. Okay. Now we have 11 protons, 11 electrons. 11 minus 2 will give me 9. So it means that I have to put another shell. Now fill in 8. The maximum that can be in the shells aside from this fourth shell here will be 8. So I'll have to put 8 here, pairing the electrons like this. Okay. So I have 8. 9 minus 8 give you 1. So it means that I still require one more shell. So I'll put one more shell here and then put my remaining electron. So this is how you draw for Rutherford diagram for sodium. The next one is oxygen atom. We start with the atomic notation, and the mass number is 16 and the atomic number is 8. So it's also a neutral atom in this case, and then it means that our proton is 8, our electron is 8 also because it's neutral, and the neutron will be 16 minus 8, which would be 8. Okay, so we have these three information. We just go ahead to draw. We have 8 protons, 8 neutrons. The inner shell, we have 2. We're dealing with 8 electrons. 8 minus 2 will be 6. So we have 6 remaining. And since the maximum that can be in this other shell is 8, it means that the whole of the space will be here. So this is the Bohr-Rutherford diagram for oxygen atom. And we can see that all the electrons has been accounted for. It's always good to also confirm that. So we have 2, 4, 6, 8, which equals to the 8 electrons that we have. Let's go to the ions, the ones with charges. Now here is chlorine ion. Now chlorine, the atomic notation for chlorine is this. It has mass number of 35 and atomic number of 17. Okay, so after writing the atomic notation for chlorine, we also do all the things we've been doing for the rest, for the ones we solved earlier. Now, the mass number is 35. The proton number is 17, so we have 17 protons. But because this is not a neutral atom, in this case, it has a charge, it will not be equal to, the atomic number will not be equal to the number of electrons. So what we are going to do in this case is to subtract the charge from the atomic number. That is how we get the number of electrons. So what is the charge of chlorine? The charge of chlorine is -1. So we have number of electrons now will be equals to atomic number minus the charge of chlorine. So in this case, this is atomic number. So in this case, the atomic number is 17 minus the charge of chlorine is -1. If we do this, this times this will become plus. So you have 18 electrons. So here we have 18 electrons, and the neutrons will be 35 minus 17, which will be equals to 18. So this means that we have 18 neutrons. So now we have all the information we need. We draw out this. We put our proton inside, the neutron inside, and then the first shell. This is what we are working with. We have 2 maximum. 18 minus 2 will give us 16. So we have a lot to fill in. So we can fill in the 8 first, which is the maximum this other shell can have. Now after this, we have 2, 4, 6, 8, 10. 18 minus 10 is 8. So we have 1 more shell to go. We fill in the electrons, each pair pairing with the other. And this completes the 18 electrons. So count it also to confirm. This will be 2, 4, 6, 8, 10, 12, 14, 16, 18. So this is the Bohr-Rutherford diagram for chlorine ion. The next one is magnesium. We draw the atomic notation for magnesium, and we have this is 24 as the mass number and 12 as the atomic number. Now, the atomic number is equal to the proton number, which is 12p2 p plus, and the neutron will be 24 minus 12, so we have 12 neutrons. And then the electrons, because this is ion, it has charge, will then be atomic number minus. So we have number of electrons will be atomic number minus the charge. Okay. So here we have 12 as the atomic number, and the charge of magnesium is +2. Okay. So it will be -2, which will be 10. So we have 10 electrons. Okay. So now we have all those information. We draw out the Bohr-Rutherford diagram. By putting our information here, we have the 12 proton and the 12 neutron. The first shell, this is the electron 10. The first shell we have 2, and 10 minus 2 is 8. So it means that this is the last shell, since it has the maximum number of electrons this shell should have. So you have 2, 4, 6, 8, 10. So this is the Bohr-Rutherford diagram for magnesium ion. All right, so the last one, the aluminium ion. We also start with drawing out the atomic notation. So you have this and that. So this is the mass number and this is the atomic number. Atomic number is equal to the proton number. So you have this as your proton number. Your number of electrons will be equal to atomic number, which is 13, minus the charge. Now, charge of aluminium is +3. So that will be -3, which will give us 10. Okay. So 10 electrons. Now, electrons will be 27 minus 13, which will give us 14 electrons. So now we have this information. We go ahead to draw out the Bohr-Rutherford diagram. Okay, so we have the inner one with these informations. 13 p plus and 14 neutrons. Then we have this. Now this is what we're looking at. So we have 2 here, and the remaining one is 8, which will give us 2, 4, 6, and 8. And this is the Bohr-Rutherford diagram for aluminium ion.